which is the linear inequalities in two variables. So in the beginning of the chapter, we did these linear equalities in two variables where we solved these systems of equalities. And so today, we're going to be starting as inequalities. Okay. So if you're taking notes, some of these terms are important. So when you take an equation and you get rid of the equal sign, and instead you put in either the greater than or equal to, or less than or equal to, you obtain a linear inequality in two variables. Okay? 135. And so just like a solution of an equality is an ordered pair, a solution of an inequality is an ordered pair of numbers that satisfies the inequality. When graphing a linear inequality, we first graph the associated equation of the inequality. So if you take the greater than or equal to, or less than or equal to sign out, and you replace it with an equal sign, that'll give you an equation that you can graph first. Each graph is called a half plane, with the line as the boundary of the half plane. So let's look at one of these. So I did this inequality 3x minus 2y is less than or equal to 8. Okay? So in order to graph that line, I want to sort of solve for y. That way it's easier to graph the line if I know the slope and the y-intercept. So I'm going to take this inequality up here and I'm going to solve that for y. So if I subtract 3x from each side, I have negative 2y is less than or equal to 8 minus 3x. And then if I sort of want the slope on the other side, so I'll just change that around to minus 3x plus 8. And then to solve for y, I have to divide by negative 2. On the quizzes in the last chapter test, a lot of the mistake that some of you made was when you were doing the slope-intercept form, you got to this point and you said, well, the slope must be negative 3 because that's the coefficient of the x. But you got to remember, that's only true if you solve the y by itself. So here, you have negative 2y. So in order to solve that for y, you have to divide this still by negative 2. And, of course, that'll give you y by itself. But one thing we do remember with inequalities that's really important, when you multiply or divide by a negative number, you have to remember to reverse the sign and do the opposite sign. So that will change to greater than or equal to. So that's really important to remember that when you're dividing or multiplying by a negative number. And then you just have 3 halves x and then minus 4. Okay, so now I solved that for the y. Now if this was an equality, if this greater than or equal to was an equal sign, if it was an equality, then I'd know my slope would be what my x coefficient, or 3 halves, or 1.5. Okay, and that's a mistake that some of you made, so keep that in mind. In order to find the slope in slope-intercept form, you have to solve for y by itself. Okay, and so if I was to graph this now, this is going to be my associated equation, because that is the line that if I took that out, the inequality sign, the greater than or equal to, and replaced it with an equal sign, I would have this line here. Okay? And so notice that my y-intercept is here at negative 4. So notice that's where my y-intercept is. And then notice that my slope here is 3 halves. I go up 3 for every 2 I go over. And so that line is my associated equation. And now notice that the y are all the solutions that are greater than or equal to. So all my y's that are greater than are shaded in. That's called a half plane. Okay? If this was less than or equal to, this would be my half plane over here where it's shaded white, or where it's not shaded at all. Now if you don't automatically see that, or if you, when you were putting your equation in, you didn't see that it's the y are greater than or equal to was over here, the y values that are greater, you could plug in a test point. So for example, that first question on both the tests were name any point that satisfies that solution. So, for example, 0, 0, I could plug in this point here. I could plug in this point here, 0, 0, into my inequality and see, does that give me a true statement or not? So if I did that, I could have 0 is greater than or equal to, well, anything times 0 is 0, minus 4. Well, is 0 greater than or equal to negative 4? Shake your head, yeah, okay. So we know that this is a true statement, which means this part here, 2, 2, is in the correct answer. So that's the shaded part. If I would have came out and got a false statement, that means that's not part of the solution, and this half plane would have been the solution. So a lot of times it's helpful if you don't automatically see that the y values are greater. And here from my y-intercept, I see that all my y values are greater than that. But if you didn't see that, put a test point in, and that'll tell you which half plane you have. Any questions so far on any of that? That makes sense? Okay. If the boundary is not included in the inequality, we use a dashed line or a broken line, and we call that an open half plane. If the boundary is included in the inequality, we use a solid line and call that a closed half plane. So notice here that I have the less than or equal to sign, greater than or equal to sign when I divided it by my negative number. And so that's a closed half plane. That's why I have a solid line here down the middle. Now when I was doing it on the starboard, you see little gaps. I tried to color it in as much as I could. If I tried to color too much, it would erase all the numbers and look weird. But it goes right up to that line. But notice that if it was just a less than sign or a greater than sign, then I'd have that line would look like this. Because that wouldn't be included. Okay? So all the points that fall on this line are also solutions. Because when it's equal to that, it is also part of the solution. So that's why we have a closed line, a solid line, a closed half plane. Okay. The graph of a system of inequalities consists of points satisfying all of the inequalities in the system. All right. So what we just drew is we drew a graph and sketched a graph of one linear inequality. So now we want to go to a system of inequalities. And so, Maggie, give me an inequality, and it doesn't matter what, just give me one.
That involves an x and a y, right?
Yeah.
3x plus 2y is greater than 4.
Is greater than 4. Okay. I'm sorry? It doesn't have to be one in the book. I'm just asking to make one up, so that's fine. Anything you say is fine, as long as it's an inequality. And so, if I want to graph this, well, I want to solve for y. So, I would subtract my 3x. And just like before, I will divide by 2. X, yes. Okay. And so what is my y-intercept, Dominica? So I know I'm going to cross right there. And I have a slope of negative 3/2. So when I have a negative slope, what is that going to look like, Austin?
You would go down 3 and over 2.
Okay, it's going to look like a ski slope, so I'm going to go downhill. And right, as I go, my rise goes down 3, I go over 2. So 1, 2, 3, and 2. And then 1, 2, 3. It's hard to see the lines sometimes on these. And then 1, 2, 3, 7. Okay. And so then as I go over 2 this way, go up 3. So that's already on mine. So over 2, up 3, and over 2. So I'm going to get a line that looks something like that. And it goes through there pretty good. And notice that, is this going to be an open or a closed line, Eugen? An open or a closed line? Am I going to have a solid? Or a broken line? So you're going to look at your sign here. If it's also equal to it, you're going to have a closed line. That means that that's going to be part of the solution set. If it's greater than, if it was less than or equal to, if it's just greater than or less than, it's going to be broken, because when it's equal to it, it's not going to be part of the solution set. So which one am I going to have? Am I going to have the closed solid line or the broken line in my equation over here? Broken line. Okay. So tools, my eraser, and make sure it's small. And it doesn't erase. Well, I don't need to.
Can you change the formatting of the line itself to a dashed line?
Perhaps.
Select it. And then go to menu. To the right. This is menu.
Right there.
Have a line down there. There you go. Sorry.
It does, but I don't. Yeah.
You gotta select it.
Yeah. But it's that line there. Okay. Good. And finally, Claire, which side of my broken line am I going to shade? I'll call this the left side and that's the right side. Where would I shade? Why do you think the left side?
Because the right side's greater than it.
Well, put in a test point, so it's easier to pick 0, I think, because 0, 0 is outside. So put this in the C. And tell me if we have a true statement. So. Okay. So let's have 0 is, and again, anything times 0 is 0 plus 2. So is 0 greater than 2? No. So that means this is not part of our solution, which means that this is on this side. And I'm not going to take the time to color in all those blocks, but that would be the shaded part. Notice also, the solution set is the y's that are greater from my intercept. But if you put in the test point, that will really help you. And so if I would, unless 0, 0 is on the graph, pick 0, 0, because that's going to be the easiest one to simplify, because 0 will just cancel a lot of things out. All right, and I want to do this as a system. So Megan, I want another equation. So give me a second equation. And I'm sorry, not an equation, I apologize, an inequality. Give me another inequality.
5x minus 7y is greater than 4.
Okay. So again, in order to do this, I want to find the associated equation. So I'm going to sort of solve, and pretend I have an equal sign there and solve for y. So I'm going to subtract my 5x. And that's a plus sign. Okay. And then I'm going to divide by negative 7. Now this is where you have to be careful, because when you're dividing by your negative, your sign is going to switch around there. And then it's just going to be 5/7 x. And that's a plus, so minus 4/7. So those numbers make it a little bit more difficult to see what's going on, but it works just the same. So what is, Megan, my y-intercept on this particular inequality? I'm using this. What will be my y-intercept? Well, we have it in slope-intercept form, where this is my slope, well, 5/7, and this is my y-intercept. Negative 4/7, which is, I guess, somewhere right around a little more than halfway. So it's hard to see like that, but that's fine. And notice, what do I have? I have a slope of 5/7, and it's positive, so it's going to go the opposite way. It's going to look like a mountain, and I'm going to go up 5 for every 7 I go over. So 1, 2, 3, 4, 5. Oh, these lines are hard to see. see, so the 7, make it easier this way. 1, 2. So something like that is where it looks like, and then hopefully this time we will use the dotted line. And okay, so that's, notice again, we have the closed line because we have the, it's not an equal to, it's just a greater than or less than. And now, Megan, when I'm just looking at my pink inequality, which side will be shaded? We'll call this the upper side or the lower side, which half plane? Let me rewrite my equation over here for you so it's a little messy here. I'm sorry, go ahead.
I don't know.
Well, pick a point that's not on this line, any point at all.
3.
3 what?
Oh, 3, 4.
You want to go 3, 4. Okay, you could do that. 0, 0 will almost always be easier for you to cancel, but you can do 3, 4. That's not a problem. That says 4 is less than or equal to 5/7 times 3 minus 4/7. And so you've got 4 is less than 15 21sts minus 4/7, and 4 is less than, you can change those both to 21s, multiply that by 3, so you have 4 is less than 9 21sts, which is, you divide it by 3 3/7. 4 is less than 3/7. Is that a true statement or a false statement?
False.
It's a false statement, which means that this point that you picked is not part of my solution, which means this is part of my half line. That is part of the solution. So if I wanted to know what the solution set of this set of linear inequalities are, these two inequalities that Maggie and Megan made up, well, it's going to be what? Now I'll change to black, and I'll say it's going to be, the line is not included, so it's hard for me to show. All these in black here, where the pink and the blue mixed, okay? Not counting the lines. The lines weren't included because they were greater than, they weren't equal to. So that would be my solution set. So any point in that black area would be a solution set. So if I went through and figured out what 9 was, if I put 9 in to either one of those, and I figured out what y is, I find out how much I go up or down. If it fell in that black section, that would be a solution set of the system of inequalities. It got kind of messy there at the end, but if I use the different colors, I think you kind of see exactly what's going on. Now, you can do more than 2. You could, we could keep going around the room, and we could have 20 of them. Everybody could come up with theirs. And the more inequalities you had, it would start to limit the actual part that might be part of the solution. And I think that there are some in the book when I went through that had 3. So you might have some where they give you 3 equations. Some of the harder ones, like 33, gave you 3 equations. But they're really not any harder. It's just find the solution set. Okay? Does anybody have any questions on any of that? That's the whole section. That's everything that they asked for in the whole section. They want you to graph these inequalities. And that's all that you have to do for all of these. So let me see. We're 47. We got a few minutes. So let's do a couple of the oral exercises. Mathematics. Math paper. Okay. So let's look at some of these on page number 138. Well, the first kinds of questions, notice that they give you a couple ordered pairs, and they say, does it, let's sit up there, Sam. It says, does it satisfy the inequality? So before you get to the graphing ones, like number 1 gives you a couple of points, and they'll give you the point 3, -4, and -3, 4. And then they give you the inequality x plus y is greater than 0. Okay? And it says tell whether each ordered pair satisfies the given inequality. So for these, you would just plug in your, notice your ordered pair is always an x value and a y value. And some of you guys had some difficulty on the test with this when they started saying solve for k, and they started putting variables in here. And when they did things like this, where they said k, 3k plus 2, that confused some of you. You didn't really understand exactly what they were doing. Well, remember, anytime you have an ordered pair, whenever it's in this parentheses like this with a comma, you have an ordered pair. All they're telling you is, here's your x coordinate, and here's your y coordinate. Okay? And then you would plug them into whatever line they gave you. Okay? So for this one here, they're just giving you numbers. But beware, eventually they might put up here a k or a k plus 2 or something, and it's really no different. So for this one here, I would put my 3 in for x, and my negative 4 in for y. And all they're saying is it a true statement or not? Well, you know that 3 minus 4 is negative 1, and negative 1 is not greater than 0. So you write no. That's not a solution for that one. And by the same token, if x plus y is greater than 0, and we put in negative 3 plus 4 is greater than 0, negative 3 plus 4 is 1. And 1 is greater than 0. And so this one is a solution set. And that's all they're getting at in that first section there. Then it says, tell whether point, now I go to the next section here, with number 7. Tell whether point P lies above, on, or below the line of L. All right. So, well, we'll do this one algebraically. Let's see. Number 7, it gives you the point 0, 2, and it gives you a line. Y equals 2x plus 1. Okay? And it says tell whether the point lies on, above, or below. Well, in order for it to lie on the line, it would have to give you a true statement when you plug these in. Again, notice you have an x value and a y value. So 2 equals 2 times 0 plus 1. 2 equals 0 plus 1. 2 equals 1. Well, that doesn't give you a true statement. So at the end, if you come up with something that's not a true statement, well, you know one thing, it does not lie on the line. It's not on the line. Because all of the solutions that are on this line would be satisfied. And that's what you had to do again on number 1 of that last test. They gave you a line and said, pick one of these ordered pairs that will lie on that line. So it's not there. So where is it? Well, let's find where the line is. Well, notice, it's already in slope-intercept form. So that tells you have a slope of 2 and a y-intercept of 1. Okay, so you have a y-intercept of 1 and a slope of 2, which means you're going to rise 2 for every run over. So this is sort of my line here. And what was I'm sorry, my point was 0, 2. So 0, 2. So once you draw your line and your point, you can see that the point lies over the line. And that's all they're getting at there. Does it lie above? And so that answer was above. Okay, number 13. Give the letter of the inequality whose graph is shown. Okay, so let's go around, Jared. How about number 13? What do you, A, B, C, or D? Which one of those is the graph that's shown?
I have no idea.
Okay.
A,
Well,
B,
notice what.
C.
All right. Well, let's write down the equation, and I'm sorry, the inequality. It's x. Again, I still don't like a good thing there. All right, Jared. I want to solve this. So how am I gonna solve this line?
-1 plus.
Okay. And I'll get x is greater than or equal to -1. What is that? What kind of line is that? From the last test. If you have x equals anything, what kind of a line is it?
Oh, it's here.
A vertical line. Right. Well, oh, did I graphed the line. Okay, so that's the picture. I see what I did. I picked the right answer and I put that one up there first. So notice that you have that x is greater than 1, and notice there's two of them that have a number. Notice the number b is a y is less than or equal to. What's that going to look like? What's that graph going to look like? Anything that says y equals something, it doesn't matter what the number is. What's that going to look like? From the last test. Horizontal line. And this is something that still threw some of you off, even with the makeup test. Some of you guys really were thrown off by this vertical and horizontal line. All horizontal lines have the form y equals something, whatever, and wherever it crosses the y axis. And if it's a vertical line, it's x equals something. Okay? So for number 13, it was C. All right. How about number 15, Sam? Do you have a book, Sam? You don't have a book?
I lost it.
You lost it? Okay. Well, you probably can't follow along then. How about you, Courtney? Number 15.
What do you want?
A, B, C, or D. That picture there for 15. Which one of those inequalities is shown in the picture?
Wait, what was the answer to 13?
It was C. I put it up there. I went backwards for him, but it was C.
I feel like none of those are right.
Okay. Well, let's start with A. So what is A? Y.
Is greater than negative x.
Well, pretend that greater than was an equal sign. What would that line look like? If I just said y equals negative x, what does that look like? Well, what would the picture look like? That's really what I'm getting at. It's already in slope-intercept form, right? Because this is telling you you have a slope of -1x and you have a y-axis of 0. They just don't write that in there. So you know it crosses the y-axis here. And what's a slope of -1 look like? It's a ski slope where you go over 1 and down 1 every time. So it doesn't look like that. Okay. Would that be that's what y equals -x looks like, that blue line. Okay? And because it's a, where's my eraser? Because it is a greater than without an equal, you know it would be dashed. Well, lovely. So it's a broken line that looks like that. Well, isn't that exactly what the graph looks like that you're doing for number 15? Mm-hmm. Okay. So it's A. So you may need to graph, if you don't see it right away, graph all 4 of them. Put them on a graph. Do you all have graphing calculators? None of you have graphing? Do some of you have graphing calculators?
How do you know which side's the shaded part?
You could pick a test point. This one, 0, 0, wouldn't be good, Claire, because it's on the line. So that's one of the few ones. But you could pick something as simple as 1, 1, and then put it in. So is 1 greater than or equal to -1? So that means that's part of the solution set. So that would tell you this whole side is part of that. Okay. And it is, oh, we have, we're good. Okay. Let's go to number 9. Well, that was for homework. Let's do number 20. Let's do number 20. And it says, it gives us a couple of linear inequalities. X plus y is greater than 0, and y plus 2 is greater than 0. So we have a couple of inequalities that we need to graph. And do you need to borrow a book? Because you won't be able to do the homework tonight without a book. I don't know what the procedure is for that. But let's see. Okay. So the first thing we need to do is substitute your inequality for an equal sign in your mind and sort of solve and say, what does that line look like? Because that's called the associated equation. It's important. And it's important that you know those terms, because if it says on a test, what's the associated equation? Some of you, if you didn't write that down from the beginning of the lecture, are going to say, I don't know what they're even asking for. So an associated equation is the line of reference for your inequality that tells you where the half plane is located. And so these are words that you need to know. So let's do that one. So in order to do that, the easiest way to graph these things is to put them in slope-intercept form. That's why we learn the different forms for the equations of these lines. And so to do that, we just subtract an x from both sides. And notice that this particular one is the one that we just did, Courtney. So it's y is greater than negative x. And so, let me pick a, oh, we can use red. How's that? So, okay, so that's the line y is negative x. And Crystal, which side am I going to shade? Above this line or below this line? And notice, I'm sorry, let me really quick, I don't want to do something, because I don't want to confuse you. So let me, notice that this is not equal to, it's just a greater than sign. So I'm going to just change that so that you can see that it's a broken line. That will be helpful. Okay. So Crystal, am I going to shade above this? Is this going to be my open half plane, or will this be my open half plane over here, on this, below it?
So you just have 0 is greater than -0?
Well, that will tell you they equal each other, which tells you it's on the line. So in order to do it, if you notice 0 is the best test point if it doesn't lie on the line. If it's already on the line, which we know this one is because it goes through the origin, then you're going to have to pick a different point to figure out which half you're at. So pick a different test point other than 0, 0.
1 and 1.
1 and 1, okay. And so, okay. So 1 plus 1 is greater than 0. 2 is greater than 0. Is that a true statement, Crystal? So what does that tell us?
So then the top of the shaded?
Right, because that point you picked is in there. So I'll just go like this. Some of you have colored pencils and really cool things for your homework you like to do. But that will save you the most time. Okay, so that is my open half plane. Okay, now I want to look at y. Do that. Okay. Y plus 2 is greater than 0. What am I going to do with this, Michael Moody? Y is greater than -2. What does that line look like? What does that inequality look like? Well, if I had a line there, if that was equal sign, what's my associated equation look like? What does y equals -2 look like? A horizontal line. Where is it going to go through? Right. So it's going to go like through here, right? Is it going to be an open or a closed line? An open line. Okay. So it's going to look like this. This takes some getting used to. So it's going to look like that. And Michael Moody, am I going to shade, is my open half plane above that line or below that line? Above. And if you notice your inequality, it says it's going to be a true statement when your y is greater than. My y values are all greater than that. But if you didn't see that automatically, you could put in a point. You could put in 0, -3, and you'd see whether you got a true answer or not. It would be because there's no x values there. So you see that you're going to be y. So we're going to shade up. And so it'll look like like this here. Okay, and I don't think it asks you here. It doesn't ask you to solve or what your solution is. But notice that everywhere here, I'm just going to put it in solid pink.
Oh my word.
Notice this. Yeah, look at that. Oh, it's spray paint. That would be my solution set, right? Because I'm above this and I'm above that line. So any point that fell in this pink shaded area would be a solution of that set of inequalities. Does that make sense? This is a pretty easy section. Everybody's got this? Okay. I think you have 2 minutes. So make sure you have the homework written down. I don't know if you have time to start one, but be quiet, quietly go about your business.